Hello everyone and welcome back. My name is SL Gamer Guy and today we have a new angle on life. Top down. Most important part of any video, the coffee. And delicious black coffee it is. Today we are going to be trying to fix this. Let me get it here. Cobra 25 LTD. We have, of course, the infamous sticker, NFG, not functioning great. So, we're going to remove that, as that's knowledge we've already attained. It doesn't work. My soldering iron's heating up. And we are going to need to disassemble this. As you can see, I've already done some pre-diagnostics on it. The diode has been removed from it as the diode was completely shot. This radio I got for free because I'm sure you can see there the meter is completely gone and a segment on the display is out. And I'm sorry if this video is absolutely awful quality. I'm using what I can. It's the first time I've ever filmed something like this. A sort of top-down view with, that's the wrong size screwdriver. Where's my other screwdriver? Oh. This is gonna have to do. My first time filming an electronics repair video like this. Usually it's just a matter of, I don't even know if you can see that. Can you see that? I think you can see that. Usually it's just a matter of filming the bench from a sort of sideways angle, but I decided to take some inspiration from good old Big Clive on YouTube and do a sort of top-down view. Hopefully he doesn't mind that I'm stealing his style, stealing his thunder. And to remove the screws, I'll put those aside for later as to not lose them. And this series is sort of going to be it's just a series about sort of fixing electronics, as essentially all I have that the normal person doesn't or can't get their hands on cheaply is what rudimentary knowledge I have about electronics. So essentially this series is just trying to take you along for the journey of my projects and hopefully trying to inspire some of you that you don't need a lab full of electronics equipment to fix something like this. So, that is my goal. All I have today are got some screwdrivers, some soldering iron, a modified multimeter, and I'll get back to that shortly, a homemade 50 ohm dummy load, so, on a bench power supply. All of which, I was going to say, can easily be obtained from Radio Shack, but I just had the sudden realization, as I usually do when talking about them, that they're not around anymore. Ours closed up, a year and a half ago. And that greatly disappointed me. I'm just going to pull out the power cable here. Set that to the side. And the old repairman's adage, see a screw, remove a screw. And just like that, I'm going to take and set the screws aside so you don't lose them. We now have a CB radio, fresh for the opening. Let's take and actually pull the diode out of its tape prison. This is the reverse polarity protection diode. Hopefully you can see that. I'm going to take and stick this over there, on the tape anyways, and pull the diode off and set that on the bench. Now all I'm doing is just opening up the back of the radio, moving technically the top of the radio, the bottom of the circuit board, as these things tend to be. I'm sure there's a reason for it, but I'm not exactly sure why. In the bottom with the speaker, you can tell because it's got the grate on it, you have to be careful opening. I'm going to open it very carefully because the speaker is attached on the other side. We're just going to carefully flip this around, give us a little bit more slack. And now, what I'd like to point out is that diode. Well, oh, I lost the diode. Oh, never mind, I didn't lose the diode. That is the reverse polarity protection diode. That being what stops the radio from blowing up if you accidentally put the negative to the positive and the positive to the negative and try to turn on the radio. Instead of frying the radio, you'll pop the diode. And that is what's happened. Now, if we flip this radio around, oh so carefully, if I can find where I pulled that diode out of here, it's going to be, where's a screwdriver, something used for pointing, here we go. We have, yeah, bit of old cassette deck belt on there. It's turned into taffy. We have 2 points from where I've desoldered it. We have that point right there. Can you guys see that? I think you can see that. We have that point right there, and where is the other point? This would be easier to show you from the top of the board, but it's going to be more difficult for me to get at the top of the board with this speaker hanging off the side. So what I'm going to do is quickly desolder that speaker. And my soldering iron right here, warmed up. I'm going to very carefully there we go. Need a bit more heat. Let me adjust my homemade temperature control, my homemade variac. That being, in the true sense of the word, a variable triac, which is the scientific name for a dimmer switch. We now have the the bottom cover with the speaker, and as you can see, I think there might have been a bit of water damage, or maybe just the humidity. It's got a bit of corrosion funk on the inside. I'm going to set that off to the side. And now, you see the power comes in right there. And as you can see, I'll pull out my my X-ray inspection tool. And you should be able to see. Down there, I have a marked out a little arrow. That's where the diode went. So essentially, the diode, let me pull a fresh one out of the pack right here. If you're doing anything like this and you plan to continue repairing electronics, don't buy a handful, buy a kit at a time. They're cheap enough, you're going to use them for something else. So if we take and open this up, find a similar diode. What are we looking for? Let's see, do we have an exact match to the original? We're looking for a 1N4003. We have a 1N4003. We don't, but we do have a 1N004 at 1 amp, 400 volts. So 1N4, yeah. So we're going to go one size up, not one size down. And I don't know who's texting me, but it's getting on my nerves. Okay, so we're looking for 1N4003. Where's that? Schottky diodes, Zener diodes. I always get the two mixed up. Got some large rectifier diodes, some larger rectifier diodes. 1N4007. Here we go. Yep. 1N4004. We're going to remove two of these. I'll get to that in a minute, as we do have 2 radios, but I'm only going to be working on one in this video. Put the pack back together. So, here we have a diode. Hopefully you can see that. Let me pull out my X-ray inspection tool again. Not an X-ray, it's a broken magnifying glass. Okay, hopefully you can see that. There's a small silver band on that diode, and what that small silver band is doing... Do I have a marker? Yes, I do. I have a marker. I have a piece of paper. I have paper towel. Good enough. So, what that line essentially is symbolizing... Well, first let me get to the actual symbol itself. That is the symbol for a diode. What does this mean? What does a diode do? A diode is essentially an electric check valve. So, what you end up having is the little electrons come through here this way. You see a little arrow there? I drew that poorly. They can go this way, forward, but they cannot go back. Think of this line in the symbol as a brick wall with a one-way door. They can go that way, but they can't go that way. And go that way, can't go that way. These are very useful, in this case, for reverse polarity. If you hook it up backwards, it will cause a short circuit between the positive and the negative of the power cable, which will then pop the inline fuse, and if you don't have a fuse, it will pop the diode. It can also be used as those larger diodes were, to rectify AC. AC being alternating current, or I believe technically it would just be alternating voltage. I might be wrong. If someone could clue me in the comments there. So let's say this. This is, I don't know, let's say screen of our oscilloscope. This is 0 volts, this dashed line. AC is going to be this. You have a positive and a negative. Now what will happen if we put a diode in series with this alternating current, alternating voltage, whichever it may be? We get, let's draw our little symbol for the diode there. Yet again, this is 0 volts. All we will get are the positive spikes. But that is for a different time. So, let's get to replacing the diode in this. So, let's get back to fixing this radio. We've got our we have our 1N4004 diode versus our 1N4003 diode, which it should be fine. I believe it's one step up from the original in what it can handle. I might be getting that wrong. I'm going to Google it. Yeah, that's the great thing about trying to get into electronics these days, is truly, you can just Google pretty much everything you need to know. So, let's see. Just Google 1N4003 diode, and first thing that pops up. Okay, so it's a 200 volt, 1 amp. So, this is a 400 volt, 1 amp, so essentially, I think we should be fine. Now we are going to insert this. Remember from our lesson of the symbol there, and I'm sorry, the lighting's horrible, but there's not much I can do about it at the time being. pull out my pointer here. So down there, we can see where I desoldered the original diode. Hopefully you can see that. I'm gonna pull out my my flashlight. Yeah, I think more people. I think everyone should have a pocket flashlight. So hopefully down there you can see. I don't know if I can see in the screen there. It's the empty space with the diode symbol, as we went over. So the diode symbol, we know that line on the symbol also equates to the line in our diode here, so we're going to eye it up and bend the legs at the proper length. Is there solder filling that hole? Yes, there is. Okay, so I'm gonna have to clear the hole here. And yes, this is a cheap soldering iron, but it is temperature controlled through a bit of classic redneck engineering, so don't worry, I shouldn't melt or destroy the board too badly. I love that smell. It's got this certain, I don't know, sort of, I guess it's the heating up of the old flux, maybe the silk screen. You just can't beat it. It's got a certain aroma to it. So now hopefully you can see down in there where I, again, I'm going to pull out my flashlight. Hope you can see down in there where I put the, put that new diode right there. You see the line is lining up with the line marked on the board. So now we're going to flip this over. And whenever you're working on something like this, take the legs, pull them taut upward, and pull them out just a little bit. And that will prevent it from sliding back through the board. Now we're going to carefully first clean our soldering iron tip. Carefully just heat up the base, add solder to the metal, wait a second, pull off, make sure that you're not joining anything you're not trying to. Same thing on the other side. And also, don't worry if your solder is not mirror shine anymore. It's because, well, pretty much all solder is now lead-free, and lead's what gave it that shine. So that's a pretty good joint. You'll notice it doesn't have the, it'll get sort of a grainy look on the outside, and it'll be gray. That's about right. It's shiny enough. Okay, well, we've soldered our joint there. I did what I could with lighting. Pulled a lamp over here. So, usually for cutting off the leads, you would use a pair of small electronics flush cuts, is what they're called. I don't have flush cuts. I got side clippers. Side cutters, there's many names for them. So, that's what I'm using. You just want to be very careful and get as close to the base as you can. And these, always have a spot for them, or else they'll end up all over your floor. The next time you walk across it, you'll get stuck in your foot with another sip of coffee. So now, I'm going to turn my soldering iron off before I burn myself. We now have installed our power diode. So what we'll do is insert our power cable into the radio. I'm going to slide this forward so you all can see. If I pull out some alligator clips, we have Yep. If I hook this up, Positive to positive, negative to negative. We pull out our multimeter and go to continuity, diode. And connect the positive to the positive and the negative to the negative. We have a voltage drop, I believe that's what that would be called, 0.049 volts. And if we flip it around, so we attach the positive to the negative and the negative to the positive, we have 0.055. Okay, now let's undo that and go to resistance. And we get and that is negative to positive, positive to negative. So with the, you can see that. The positive going to the negative lead going to the positive lead. And then if we flip this back around, negative to negative, positive to positive, we get... Oh, is that because it's on? Let me check that. Yeah, okay, there we go. So positive to positive, negative to negative, we get overload. So we essentially get infinite, meaning it's not connected. And then if we take and flip it around, I don't know if this is actually going to work. It might be completely switched off. To 5 point. Okay, yeah. So everything's reading good for now, I think. I have a good feeling that I've done this correct, and that's all that people seem to care about these days, is their feelings. So I'll take and where is its microphone? Oh, number one thing, if your radio's acting up and you check the diode, and the diode seems fine. Two other things to check. If you've got no audio coming out, obviously, check the speaker. If your radio doesn't have receive, also, check the microphone. The microphone, it completes the circuit on the inside, I guess is a simplistic way to put it. What I'm going to do is where are my alligator clips? Where are my alligator clips? There's the, did I mark that? Yeah. We're just going to hook up the speaker with some jumper cables here. That's all I'm doing out of camera view, because I don't think you can see it. And, we'll flip it right side up so you can hear it for the sake of it. Shorting? Nope. We're good. We have power from our DC bench power supply. And hook that up. Positive to positive, negative to negative. I'm not concerned about it not having a fuse in line with it because my bench power supply can only deliver, I believe it's 1.5 amps. Yeah, 1.5 amps of current. And once it has reached that, a breaker will trip on the back of it. And I've done that a couple of times, so I know it works just fine in that aspect. So, now if we... Actually, I'm going to disconnect it. Power supply on. Volts. Yep. And the radio is off. Connect the jumpers. And on. The radio jumps to life. It's in receive. You can hear the static coming out of it. Hopefully. Is this filming? Yeah, it's filming. So if I carefully sort of move this around, you can see the radio is indeed on and functioning. Oh, I don't want the speaker to short out. So now, what we'll do to test transmit is one of the most sketchy things I've done to date. And you know it's sketchy, but I admit to it being sketchy. And take our drill bit, and going to insert it, there you go, into the back of the SO239 connector. We're going to take a jumper lead, connect it to the drill bit. I'm going to take another jumper lead, connect it to the outside of the SO239 connector. We're going to take our homemade 50 ohm dummy load and connect it to this. This might break this radio, which is why I'm working on this radio first, because I couldn't find if these were wire wound resistors or not. So essentially, I'm going to try and lay out the wires in a straight line, so that way the RF will hopefully sort of cancel itself out. Doubtfully, but possibly. So we have our 50 ohm dummy load going to the back of our SO239 connector. We have our speaker hooked up, we have our microphone hooked up. Now, you might be wondering, what is this doing at all? Well, this dummy load, if it's going to work properly, and these aren't wire wound, is going to absorb 80-90% of the power that this radio is putting out. So what that means is we can use, let me get it out here, we can use this. The astute among you might have noticed this is an analog multimeter. How on earth can we use an analog multimeter to test for RF? Well, that's because this is modified. As you can see, that might be backwards for you. Field strength meter, do not use for voltage. We have what is it? Male type, right? Male type? I think it's male type. F-type connector. Inside here is a, I might as well just take it apart and show it to you. It's a really simple trick that you can use. It's a couple of diodes and a capacitor wired up in just the right way as to make a converter. For those of you who like to use your laptops during long card trips or whatnot, you'll know that you have an inverter. Takes the 12 volts from your car and steps it up and modulates it to 60 hertz, 110, 120 volts, somewhere around there if you're in North America. A converter is the exact opposite. It takes the AC and converts it back to DC. And this here, if I can carefully move it around and show you, you'll be able to see in there. There's two Zener diodes and a large capacitor. I hope I'm getting that right with the Zener versus Schottky. I can never seem to get those correct. So, essentially, if we just put this back together, put the screw back in, all this is doing, RF, is just alternating current. Alternating voltage, whatever it may be. I'm still confused on that subject. So, you just get, this is top down, so you get this. You get positive and negative spikes crossing the plane. So all this is doing is converting it to DC and measuring the DC. So what we're going to do is I'm going to hook up a probe to it. We're going to set this for a small range of 0.5 volts DC. I'll push this back a little for you. And there's the meter. Make sure our dummy load's hooked up properly. I'll sort of drape this along the bench there. Are we getting anything out of this? Usually it's such a low scale, it's got a... such a low scale, it's usually reading something in the background already. Let me just short this out. I don't know if it's doing anything. Oh well, for the sake of it. It also does seem to work well if I attach it to the F-type connector instead of one of the Still want the front panel jacks on it, so I'll do that as well. So we have 1/2 volt scale. If I turn this on, do we get anything? I don't think we get anything. It's odd though. Just have static coming out of our dummy load. That might be working as an antenna. Yes, it is. That doesn't look good for us. Oh well. Oh no, it's got a sketchy mic switch on it. That's what I forgot. So, if we take and go to a lesser used channel, just in case we take and radiate, let's go to 20. Make sure we have this set on here. Bright, dim, normal, RF gain. Let's turn that way down. Dynamic halfway, squelch down, volume pretty much down. If I, whenever I key the microphone, you should be able to see that move. If not, peg. There we go. So we're getting power out of it. That's good. So now, let's take and bump it up one scale. Let's go 10 volt scale and see what happens then. See how many amps are we drawing? We're drawing about 1/4 amp idle. As you can see, that capacitor, it just smooths everything out, so you get a more even jump up. Then we go down to 2. Testing 1, 2. It's too high. Go there. I don't know. Testing 1, 2. Testing 1, 2. Testing, testing. Okay. So the finals in this seem to be just fine. I'm going to take and let them cool down a bit. As that's this thing, I do believe we might be causing a bit of unnecessary stress on them with that, as it might be throwing some inductance their way. Now what I'll do is, instead of having this hooked up to our dummy load, turn that off and save battery, I'm going to hook it up to, I'm going to keep that on for the sake of it. I'll hook it up to my big external antenna and test the receive. Yeah, you should be able to get something, especially on a good night like this. Dry, clear sky, low humidity. And take and hook this up and kick it back on. We should get an earful of static. So thank you guys very much for watching. If you've enjoyed this video of fixing the Cobra 25 LTD Part 1, I'll go through sort of giving it my best screwdriver tune-up and essentially comparing it to a known good radio as a receive and transmit to each other, test that. And yeah, with that being said, if you've enjoyed this video, please let me know by telling me down in the comments what you enjoyed about this video, what I did wrong. If any of you can explain to me alternating current, as it seems to me it should be alternating voltage, please let me know down in the comments as well. So, yeah, thank you very much for watching. You know what to do if you have enjoyed this video or disliked this video, and I will see you in the next video.